All right, so this limit has absolute value, so this one is a little bit tricky. Uh, I am finding the limit as I approach 0 from the left. And of course, you know that if you try to do it the fast way, you will get something like 0 over 0, which is of course not possible. What we want to find here is some way to factorize it. Um, but actually, there are no factorizations that we can do here. That's why this is tricky. To solve this exercise, you need to remember the definition of the absolute value. And if you remember the definition of an absolute value, it's that it is actually a piecewise function. A piecewise function that tells me that I should apply x when I fall into the range of x equal or greater than 0 and minus x when x is less than 0. All this means is if x is a positive number, leave it like that. If it is a negative number, multiply it by negative. For example, the number 5 falls into this scenario, and then I just do nothing. But if I would give a negative 5, it falls into this scenario. And what I have to do is multiply it by negative 1, which is 5. Okay? The absolute value function, remember, is a function that always gives me a positive number. So for this one, you need to remember this definition. Because if I remember that definition, then I can rewrite this function here. This function that I'm given here, I can rewrite it as a piecewise function. And then I would have something like x over x whenever x is greater or equal to 0, and something like x over minus x whenever x less than 0. Okay, all I did is replace this absolute value in the denominator with the definition here. Okay, so yeah, that is my function written in a piecewise function way. But I can still factorize a little here. Well, not factorize, but divide. What is x over x? That is 1. What is x over x? Negative 1. You see? If I were to draw a graph of this, I would have here my x and y axis. I have here 1 and negative 1. Okay? This part here, it says for all of the x that are less than 0, choose negative 1, like this. And then this space. And then for this part, all of the x that are bigger than 0, choose 1. So my function looks something like this. You see? Once I have this graph, I am now able to find what is the limit as I approach from the left to 0. If I approach from the left, I'm coming here, here, here. Boom. And what is the value that I am approaching from the left? From the left is negative 1. Negative 1. Yeah, that's all. If you were to approach this from the right, well, you would get to 1. Okay? That's how you do this one.